All right, so in the last video, we talked about wanting to store information using a key like cyan or pink or H or any string. And by the way, in a hash table, it doesn't have to be a string, but we're just going to focus on strings just to narrow down some of the complexity. But either way, whatever we use, it's not a number. So let's say we're using a string like cyan rather than a number like 0 or 2 or 1 million. This is a lot clearer. So we want human readability, but of course it needs to also work. It needs to be a real thing on our computer. And unfortunately, computers don't know how to find something or insert something at index pink or index hello world or out damn spot or H. Computers don't know how to do that. Thankfully, we have hash tables to the rescue. Okay, so quickly, just a little preface here. Remember that every language, at least every language I've worked with, has a built-in implementation of a hash table. We are actually reinventing the wheel here, which is usually something I try and avoid in these courses, but it's just to help us understand how this works. It's important to understand what's happening behind the scenes. I like to think of it as, we're building a little model, like a toy model of a car engine on our desk to help us understand how real car engines work. If you actually had to use one, you would probably pick the Ferrari engine that you magically have laying around in your house rather than the toy model you built out of cardboard. But either way, you understand how they work now. I don't know if that's a good analogy, honestly. So that's what we're doing. We're trying to build a model to understand how it works. And to do that, we're going to use an array or a list, a way of storing information where we have to use numbers. So what we do in a hash table is we take an input. Again, we're narrowing it down to say strings like hello or pink. We need a way to take pink and turn it into a number that we can store in the array. So if our array goes from 0 to 99, it has 100 slots, 0 to 99, we need a way to convert pink to a number between 0 and 99, and then we store the data at that number. So there are functions that help us do that, and they're called hash functions or hashing functions. I'll actually have a separate video after this one where I talk about the complications of writing a good hash function, why it's difficult. We'll talk about some examples of existing famous hash functions. They are used all over the place. There are very intense teams of people, like multi-country efforts of people working on hash functions because they have a lot of applications in security and cryptography. But what we're talking about are going to be very simple, limited in scope hash functions. The idea is we pass in a string. If this is our array where we're storing our data, we have 10 slots. We pass in a number to our hash function. There are many, many implementations, just some mysterious hash function over here. I guess you can't see where I'm pointing. To my right, it's a box. If I pass in the string pink, it needs to give me some number between 0 and 9. And every time I pass in pink, it should give me the same number. So it happened to give me 0, the way this hash function is worked, the way this hash function is built. It gives me 0, so I store pink as the key and then this as the value at index 0. Then I go to the same hash function and I say, hey, here is orange red. What does that convert to? Well, it happens to convert to 7, so I store it at 7. I do the same thing for cyan and I get 3, so I store it at 3. So that's how we go about storing things. Now, if somebody asks me, hey, what's that index, index cyan? Well, our code still doesn't know what index cyan is, but I can take cyan and pass it to the hash function again and say, hey, what was the number you gave me earlier? And it gives me 3. And then I go to index 3. Same thing for pink. So this is why it's important we always get the same number back. If that doesn't happen, then this whole thing is broken. Because if I ask for what's the index of cyan and it gives me 9, there's nothing here. It always has to be the same thing. Once we've inserted something, we need it to be consistent. So writing a hash function that works, that takes a string or any piece of data, an image, a PDF, a video, and somehow spits out a number, it's not easy. And that's what we'll talk about in the next video.